Hi everyone, I'm Stas, welcome to my channel. And today we're looking at how to run large language models on Tenstorrent hardware, and we'll compare it to a more traditional approach with an Nvidia GPU. So let's get started. For this video, we're using Llama 3.8 8B instruct model. So to get started, we need to navigate to Hugging Face, find this model, log in, and request access to it. Please be aware that getting access may take a few days. Now let's install Hugging Face CLI. According to the manual, it's pretty straightforward. Just the pip install. And now we need to log in into Hugging Face account using Hugging Face CLI login and enter our token here. Press enter, don't get this git credential, and we're authorized. Now let's figure out how to run our model on Nvidia hardware. Let's start with creating a virtual environment. Python 3 -mvenv. Let's call it vLLM CUDA. So now we need to activate the virtual environment, source vLLM CUDA being activate. Okay, now let's install vLLM. vLLM is supposed to just run our model on CUDA hardware without any intervention. Let's see how it works. Now vLLM is installed. Let's check that it installed the correct version of PyTorch. So we'll run Python import torch. Torch CUDA is available. False. Yeah, so let's go and manually fix the situation and install Torch with CUDA support. So let's figure out which version of Torch does it want. Torch version 251. Okay, let's navigate to PyTorch website and get started. Install previous version 251 using wheels. Now we need to figure out which version of CUDA do we need. It's easy to do. We run Nvidia SMI, and here it says version 12.4. So we need to install 12.4. And to force the reinstallation, we're gonna add -u flag to pip install. Let's wait for the installation to complete. Okay, that seems to be it. Let's check that Torch is installed correctly now. Import Torch. Torch CUDA is available. True, perfect. Now to serve our model, we should just make a simple call vLLM serve and the name of the model, which is Llama 3.1 8B instruct. And that should be it. In the first run, it may take a while to download and initialize the model, but it should be working pretty quickly. Yeah, so now it's downloading the weights. Let's wait for everything to complete. Running the model failed, and if you look at the error, it says the model's max sequence is larger than the maximum number of tokens that can be stored in QB cache. Okay, it says increasing GPU memory utilizations or decreasing max model length. Let's do this. So we go to vLLM serve and specify max model length to be 4096. So let's see how this one works. And now it succeeded. So right now we should have a web service which serves our model with OpenAI compatible API. But before we're going to test it, actually we'll figure out how to run it on Tenstorrent hardware first. So this way we can run them side by side and compare. Running the model on Tenstorrent hardware is a little bit trickier. First, we need to navigate to Tenstorrent fork of vLLM. It's located at github.com/tenstorrent/vLLM. Here we need to navigate to dev branch, then go to ttmetal folder, and here we have an actual readme of how to use it. The first step is to set up ttmetal. We already did this in my initial setup tutorial, which you can find in the video description. So now let's move to the second step. We need to clone vLLM repo. So let's go to the code and clone. Let's open a new tab and clone this fork of vLLM. Check out dev branch. Now proceed with their instructions. Export. Source. Okay, now we need to execute this from ttmetal directory. My ttmetal is located in home folder, ttmetal, build metal, create venv. Okay, let's run it. If you're doing this for the first time, it may take a while. Okay, now this step is complete. Let's go back. We need to activate the environment, source, Python env bin activate. And then just do pip install, but before that it wants to stop great pip. Interesting, but most likely it is important. Skip it and install. Let's see how it goes. Okay, so installation succeeded from the first try. Now we need to figure out how to use it. Unfortunately, it's not that simple. Here it says that we need to access models on Hugging Face, which seems straightforward, and login. We already did this. Okay, now they want us to follow demo instructions. Let's see what they have here. Llama 3, models, how to run. Here it says download weights directly from Meta. Okay, let's go forward and do exactly that. So let's request our access and download Llama 3.88b. For some reason this button doesn't work. If the same happens to you, you can try another browser or use incognito mode. For me, this worked in incognito in Chrome this time. Okay, now we have installation instructions. Let's go through them. Let's start with installing Llama stack. Pip install. Installed. Llama model list. And where is our model? 3.8 8b instruct. Here it is. And here its name. Okay, now we need to do Llama download source meta model ID. Model ID here. And copy a URL. Let's wait for the download to finish. Okay, now download is complete. Let's continue with the setup. Okay, let's go back. How to run? 70B only, multimodal only. Yeah, step environment. Export llama dir equals model directory. Let's do this. Okay, so the weights were downloaded to homestas.llama checkpoints Llama 3.8b instruct. Export. On N150 and 383K. Currently I'm running Tenstorrent Wormhole N150, so most likely this command is for me. Let's run it. Yeah, then it goes run the demo. Let's go back to vLLM instructions and see what they do here. Yes, running the server example. They export some variables and run server example ttpy. We should do this, but before we do, let's take a look at this Python script. Okay, here it's a specify specific model, block size. Okay, let's try it. vLLM RPC timeout, mesh device equal. I have N150, so I'll write it here. Don't really know what it means. Python example model, and the model name is I guess meta llama. This. Let's see if it works. So after a short investigation, I figured out that we actually need to run this pip install command in ttmetal. Go back to vLLM and execute our command line. Copy N150. And then specify a model. A list of models. It shouldn't be this. Struct. Oh, missed a space. Okay, it says address already in use. Well, let's terminate Nvidia for now. Go back and run again. And it seems to be doing something. Let's wait for it and see. Okay, and after a while it seems to be working. So let's go back and restart our Nvidia version using a different port. Let's say 8001. Okay, so we currently have Nvidia version running on the port 8001 and Tenstorrent version running on the port 8000. So let's go ahead and compare them. So here I prepared a Jupyter notebook which we'll use for testing and comparing Nvidia and Tenstorrent servers. Let's go through it step by step. First we install OpenAI library, import it, and create a client to OpenAI API which connects to localhost 8001 for Nvidia. And we start measuring time, create a request to chat completions to our model, and the request is help developer to debug application. Hello, generate a very long text. I'm testing API and performance. And we limit maximum output tokens to 500 and set temperature to 0. And we output elapsed time and the response from our model. Let's give it a go. Okay, here you can see it took 8.6 seconds to do. And here is a response. It says here is a long text for you and a long text. Okay, let's do the same for Tenstorrent. It's basically the same code, but it connects to port 8000 instead of 8001. And let's see how Tenstorrent does. Okay, and here we got a response in 19 seconds. It's a little bit different. It starts a little bit differently, but the main content is basically the same. It's roughly the same lorem ipsum in both cases. Okay, so we have successfully deployed a vLLM server which hosts a model with OpenAI compatible APIs on both CUDA and Tenstorrent hardware. Now let's go to results and compare the performance. I put our data into the spreadsheet, and as you can see, N150 is about twice as slow as 4090. So I added another contestant into this chart, which is Tenstorrent N300, which is another card Tenstorrent makes, which is supposed to be significantly more powerful. And based on the specs alone, I estimated its performance. So take it all with a grain of salt. But on this chart, you can see a slow progression from N150 to 4090. But this chart doesn't really paint the picture, because those cards have drastically different prices. So I try to summarize their prices in here. So N150 costs $1,000 and 300 is $1,400. But the question is, how much is Nvidia GPU worth is very arguable. So I bought my 4090 for $2,000. That's what I'm gonna put here. Currently, the prices vary so much, it's hard to predict what they're gonna be. Using those prices, I built a green chart, which is performance per dollar. And as you can see, all of the three contestants are very close to each other, with N300 having a slight lead over both competitors. So, what kind of conclusions can we make from this? To be honest, not much. This is a single test, ran on a single query on a single model. So, yeah, your results may vary drastically depending on the use case. But what we can see, even from this data, is that Nvidia seems to produce more powerful cards than Tenstorrent accelerators, but performance per dollar already seems comparable, even better in some cases. It seems like Tenstorrent can actually put up a fight to Nvidia's domination in the market. So let's keep following and see how the situation develops further. Thank you for watching. If you enjoyed this video, please like and subscribe, and hopefully see you soon. Have a good day.